All right, this video is going to go over 12.2c, which is rationalizing denominators. I don't have the notes for it, so we're just going to work on the homework. This is something that's definitely important in college, so you're going to want to remember this moving forward. But anyways, here we go. You're not allowed to have roots on the bottom of fractions. So like 5 over root 2. This is considered a no-no. You can totally have roots on the top. That's okay. But you can't have roots on the bottom. And so what you have to do is you have to rationalize your denominator, generally by multiplying by whatever's on the bottom, like this. But not always. So let's look at some examples. The first one is root y over 3. Well, you need to be picturing it in your head as root y over root 3, okay? Now, you're not allowed to have this root 3 on the bottom. That's not okay. So what you do is you multiply by that, root 3 over root 3, because this right here is 1, so you're not actually changing the value of anything. So if you do this, you'll get root 3y over root 3 times root 3 is just 3. This is what my answer would be. That's all you have to do. So like, look at the next one. It's root 5 over root a. Well, you're going to times by root a over root a. So you're going to get root 5a up top over a. And by the way, do not cancel these a's. Don't do that. You can only cancel numbers out here with numbers out of the root, okay? You'll see some of those examples, I'm sure. All right, this next one. It's over root x, so you're going to want to times by root x over root x. Now, what you're going to get is root 27x over x. You might think you're done there, but you're not. You have to still kind of break up 27 to call it square root of 27 is 3 cubed. And so now you can be like, oh, okay, I can kind of simplify that some. I can take a 3 out, just one of them, and then left over in that root is a 3x, and this is all over that x. And if you're wondering what I meant when I took that 3 out, I have other videos going over that lesson. We've already covered that. So let's look at this next one. Root 4 over root 5x. Well, hit it with a root 5x to rationalize that denominator. And so you're going to get root 20x over 5x. Well, you'd still have to break up root 20. Root 20 is the square root of 2 squared times 5 to the 1 times x, and it's all over this 5x. And so you should realize you can take a 2 out. Left over in the root is 5x, and then it's all over that 5x. And yes, you could have just called this 2 right from the start and had 2 root 5x over that 5x. Same thing. Okay, the next one. Hit it with a root 3y to rationalize the denominator. So you're going to end up with root 24x. Getting ahead of myself there. Root 24xy over 3y. Okay, now root 24, you need to realize if you break that down, it's the square root of 2 cubed times 3 to the 1. And so you can take a 2 out. Left over would be a 2 and a 3, which is going to make a 6 xy over this 3y. If you're wondering how I got this 6 right here, we took a 2 out, but there was still 1 left over. So it was like 2 to the 1 times 3 to the 1, making 6. Okay, the next one. rationalize the denominator. So hit it with the root 18x. So now it's root 18xy squared over 18x. If you break up root 18, that's 2 to the 1 times 3 to the 2. Then you had that xy squared. All right, so you can take a 3 out, and you can take a y out, and left over is a 2 and an x. And it's all over this 18x. Now, this is what I was talking about earlier. These things, roots and stuff outside of the root, cannot help each other out in reducing, but the 3 and the 18 can, the numbers outside can. So you would want to reduce these and get 1y root 2x over 6x. Okay. Now, sometimes when you rationalize these denominators, it's a binomial down there. These are a little bit more tricky. And so let's first run through some FOIL and see what it's going to look like when we do multiply these out. So I'm just running FOIL here. So like first is 3 times 1, which is 3. The outside is 3 times root 5, which is plus 3 root 5. The inside is 1 times root 5, which is plus 1 root 5. And the last is root 5 times root 5. Root 5 times root 5. The root just goes away and it just drops to 5. So it's like plus 5. All right, so now you have like terms. Like this, these are like terms, and the 3 and the 5 are like terms. 3 plus 5 is 8. And then 3 root 5 plus 1 root 5 is 4 root 5. This would be my answer. All right, so the way that most of these are going to work is they're going to basically set you up with a difference of squares. Here's what I mean. The first would be 3 times 3, which is 9. The outside would make 3 times minus root 7, so minus 3 root 7. The inside would be root 7 times 3, so plus 3 root 7. And the L would be root 7 times minus root 7, which is minus 7. Now, when I said difference of squares, it's a difference of squares when the outside and inside cancel each other. So really all you're left with is 9 minus 7, which is 2. Okay, this next one, it's the same thing. Just picture it written twice. Like that. So the first is root 2 times root 2, which is just 2. The outside is 2 root 6. Nope, sorry, 6 root 2. Getting ahead of myself there again. 6 root 2. The inside is 6 root 2 as well. And then the L of this would be 6 times 6, which is 36. So combine all your like terms and you get 38 plus 12 root 2. And if you're wondering, can I combine that 38 and the 12 and just call it 50 root 2? The answer is no. They are not like terms. Okay, the next one's difference of squares. So when you get good at these, you can just kind of ignore the outside inside because they're going to cancel anyways. But I'll write it all out for now. That way you don't get confused. The first would be 5 times 5, 25. The outside would be 5 root 11. The inside would be minus 5 root 11. And the last would be root times a root. The root goes away, so it just turns into minus 11. So here's the outside inside canceling, and it's just 25 minus 11, which is 14. And then this last one, this one's kind of trickier. So when you do this first times the first, you have 2 root 6 times 2 root 6. 2 root 6 times 2 root 6. Okay, the 2 times the 2 is 4. And the root 6 times the root 6 is 6. So it's actually 24. Now the outside would be like 2 root 6 times minus 3. 2 root 6 times negative 3. Well, that's just negative 6 root 6. The inside would be, let me draw that a little better. This is the inside, would be plus 6 root 6. Same thing as blue, basically. And then the L of this FOIL would be 3 times negative 3, which is minus 9. All right, so your outside inside cancels again, and you end up with 24 minus 9, which is just 15. So the reason we just practice that is because sometimes when you're doing this, when you're rationalizing the denominator, you're going to have binomials. So if you have a binomial, that's not right. Binomial denominator. You need to make your own difference of squares. So here's what I mean. It says 1 plus root 3 on the bottom. There's a root there. I cannot have a root down there. So the way you fix this is you hit it with a difference of squares. 1 minus root 3. 1 minus root 3. Because what's going to happen is, let me just do the denominator real quick. So I'm only talking about the denominator. You're going to have, FOIL it out. You'll have 1. The outside would be minus root 3. The inside would be plus root 3. And the L would be minus 3. And if you notice, these guys are going to cancel. And so on the bottom of your answer, it's just going to be 1 minus 3, which is negative 2. Now the top, you will have to distribute. So it's going to be like this. 4 times 1 is 4. 4 times minus root 3 is minus 4 root 3. And the majority of the time you would be done here. Only problem is all these numbers, they all have to be reducible. These numbers, not the root, the numbers out in front. If they can reduce, they reduce. So you have to reduce it. I would divide it here. So 4 divided by negative 2 is negative 2. Negative 4 root 3 divided by negative 2 turns into plus 2 root 3. I'm simply dividing the numerator there by negative 2, since both of those numbers could reduce. Now, if this had said, for example, 4 minus 7 root 3, then I wouldn't have done this because all those numbers are not divisible by 2, for example. Okay. All right, let's finish this up. This last one, you have to make your own difference of squares. So you're going to hit this with a 2 plus root 3. All right. Let's talk about the bottom first. The bottom, if you FOIL it out, you're going to get 2 times 2. You're going to get the outside as plus 2 root 3. The inside is minus 2 root 3. And the L of this would make minus 3. So the bottom of this is these cancel, and it's just 4 minus 3, which is 1. So that's nice. Now the top's the tricky part. This right here, you're going to have to run FOIL. So 5 times the 2 makes 10. The outside is 5 root 3. The inside is 2 root 3. And the L is plus 3. The L, root 3 times root 3 is just 3. All right, now combine your like terms. And you get your answer. And since it's over 1, you don't even need the over 1. So that's rationalizing your denominator. You will definitely need it in college, so make sure you don't forget it. Hope this video helped.